Awesome. Thanks so much. Yeah, so I'm Patrick Little from federal government's open data portal. And today I'm going to talk to you a little bit about how we're using CCAN in innovative ways for high quality data publishing on the portal. Can I get the slides? Sweet, thanks. Oh, sorry, pointing the remote on the wrong direction. Perfect, thanks. Yeah, so the Open Government Portal is really a collection of 3 applications that work together. We're using CCAN as our data management data management system, and Drupal for our web content management, and a couple of sort of advanced visualizations of data sets using Django. On the portal, we have about 34,000 data sets or open information assets right now. And we also have about 2 million structured reports. These are like our proactive disclosures, such as like contracts, things like that, from over 150 different Government of Canada institutions providing content on the portal. Yeah, as I said, so in this session, we're going to focus on innovative ways our team has been using CCAN to deliver high quality open data. I'm going to talk now sort of about a product roadmap, where we are and where we've been and where we're going. So when we first started using CCAN, we were really just using CCAN to manage metadata. Data publishers had to bring your own storage. So at the time, back in 2013, pre-cloud, this was, finding a server in a data center someplace to host your CSVs, talking to the person who runs that. Hey, please upload this on this day. And then using our centralized system for the Government of Canada to manage your metadata. Once we moved to the cloud, that unlocked cloud storage. And we were able to offer something called the CCAN file store, where data publishers could just upload the files directly into our system. But with this cloud storage extension, there's no understanding of what's in the data itself. You don't know how many rows does this data set have? What are the columns? What are the data types? So we wanted to go and move a little bit to step forward a little bit and start offering what's called the CCAN data store. So this is new for us, just since about Easter of this year. And with the CCAN data store, you're managing your metadata just like you have previously, but instead of just having a blob storage of the data, now we're loading those tables into a database. This allows the system to understand what is this data? How many columns are there? What are the row names, or sorry, what are the column names? And it also unlocks the ability to query the data using an API. It gives you data dictionaries that, so users can see what's in that data before you download it. And it will give you also some automated validation on that data to make sure it's well structured. So this is new for us, and this is kind of where we're at currently. We'll talk at the end about Table Designer, which is a new feature that the team's been working on and that we're working towards this year. As I mentioned, with the CCAN data store, you get the data store API, you get the automatic format conversions, previews of the data on the page, which is, a big user experience increase for folks, and you get the data dictionaries. Just looking at it in a little bit more detail. So, on a resource, on a data table that is loaded in the data store, you get that nice little green button that says Data API. And then you get instructions for the user on how to query that data set. And then, there's some instructions for Python, some instructions for JavaScript. Yeah. You also get sorry, I didn't realize there was an animation there. You also get automatic format conversions. So for things that are in the data store, if, it's published as a CSV, but if I'm a user who wants to consume that data in JSON format or XML or as a tab separated values, the system can just do that format conversion for the user automatically. We also get data dictionaries on the data. This is super great because, as I said, a user can see what's in this data set before I maybe download a 2 GB CSV that takes, hopefully not too long, but could take a few minutes to download. So you can at least see at a minimum a little bit about what's in that data. For us, it was a little bit challenging for us to implement this in the government of Canada because multilingual support for the data dictionary was a must-have feature for us. So we spent a bit of time sort of adding internationalization to the data dictionary feature, which, again, we're happy to sort of push that back up to the open source community. The other big sort of game changer feature we get with the CCAN data store is the data previews. So here you can see the actual data on the page itself, and it unlocks a number of functionalities. For one, you can do a simple text search within the data set, and then it will refine, the preview on screen to what matches your search query. You can also add filters to narrow it down. And you can hide or remove columns because you might have a data set that's 40 columns wide, not very previewable on screen. So you can show or hide columns to make it more visible. But one of the best features for this is once you've sort of set up that preview with whatever sort of features you want, whatever filters, whatever columns, then you can download that as an extract. So say I'm only interested in government contracts from a certain department between, these two date ranges. You can set up that query and download just an extract of that data, which works great, especially as some of the data sets get really big. So now you can, as opposed to downloading, a several gigabyte file, you can download just the relevant data that you're looking for. All right, so switching a little bit away from system features, I just want to talk a little bit about the decentralized publishing approach we use in the government of Canada. So as of the 1st of November, we had a little under 4,500 registered users of the data platform, meaning 4,500 government of Canada employees have access to this system to publish data across actually 343 different government of Canada institutions. So with this level of scale, 4,500 data publishers, it's a bit of a challenge to keep the community all trained up on the intricacies of every function. And as people turn over, some of that experience and knowledge needs to be refreshed with the new cadre of people coming in. For certain organizations that use CCAN, they really centralize the publishing of data within a core team of power users. And for those groups, they might be comfortable, having not like a lot of automated validation on data, having the sort of validation be done at the human level. But for us in the government of Canada, we want to make sure that any of the data that we're previewing using that interface, any data that we're serving through our API is formatted in a well-structured way to give expected results for users. We also find in the government of Canada that there's a big gap between the tooling and skills available on sort of the most empowered teams and the least teams. Certain teams are set up with best in breed implementations of the modern data stack. Other teams really just have Microsoft Excel available to manage data. So, in the next few slides, we'll see what are we trying to do as the operators of the data platform to make things easier for maybe the without folks. So the first sort of thing that we implemented is data validation. So this uses the CCAN validation extension that runs all of our tabular data through a library called good tables that does really just structured checking of the data before it's published. When you upload it on our internal system, users will see a little colored badge that if you click that, will go to the validation report for that data set. If your data is good to go, you'll get a nice green badge. It'll say, yeah, data valid. It'll tell you, how many rows, how long it took to run the validation check, that type of thing. If your data is not valid, you'll get a angry red badge. And when you click that validation report, most importantly, you're getting a detailed, actionable report on what's wrong with the data from a structural perspective and how can you fix it. So it'll tell you, what the particular check that failed was, but actionable feedback on how to correct the issue. Yeah, there's a couple different badges available. Sometimes, it's our bad and we have to give a badge saying, oops, there was an error. But we're doing a few core checks. We're checking to make sure that every column has a header name, making sure that none of those columns have duplicate headers, making sure that there's no blank rows in the data set. We're making sure that there's no duplicate rows in the data set, making sure that no rows in the data have more values than the header, and making sure that none have less. So this kind of ensures that the data will be at least queryable through the API. For the Government of Canada's implementation of the CCAN validation extension, we're only showing these badges internally. We weren't quite ready or not really sure on if we want to sort of name and shame on the public website, but this gives the data publishers that actionable feedback they need to make those changes. And I wanted to sort of highlight the fact that you shouldn't have to be, a super data scientist or, an old school DBA to be able to interpret that feedback and make those changes. It's designed to be actionable feedback for folks. So this current approach with using the data store is working okay, but there's a few sort of core limitations. The first one is to add a new version of a data set. Typically, users will do that extraction from the source data system and then push the new version of the data set to the portal, either using our user interface or using the package update API call. This is okay for small data, but for large data sets, you're transmitting a lot of data. Every time you're doing a new version of the data set, you're transmitting the entire data set. So, if you're updating a 4 or 5 gigabyte CSV 3 or 4 times a day, geez, you're chewing up a lot of internet usage. The other issue with that is, or the other sort of limitation with our current implementation is there's no real sort of interface or templates or good detailed API documentation to manage that data at the row level for the data publisher. It is possible to use an API call called data store upsert to add new rows to the data set without transmitting the entire file every time. But we haven't seen that commonly used by data publishers so far. Aside from the core CCAN data store, an innovative way that our team is using CCAN is with something called the recombinant extension. So in this extension, a team like our team creates a definition file that defines what the data set is, including what fields go in that data, what are the primary keys for the table, what are the data types for each field, and any sort of validation business logic that should be built in. This definition file is used to sort of define the user interface elements in recombinant, and it offers three different ways for data publishers to manage the data. There's a Microsoft Excel template. There's also a web form, and there's the API, but it will give you like very specific API guidance tailored to the specific data set. It also gives you a nice preview interface to see what data you've uploaded. So if we look at this in a bit more detail here, so here's an example of what recombinant looks like to a data publisher in the government of Canada. On screen, you can see here, I apologize, it's a bit small. On screen, you can see what it looks like for a data publisher who's updating, for in this particular case, the reporting for the 5th National Action Plan on Open Government. So on the interface, you see there's a button to download an Excel template and then upload it back in. There's also a button called Create Single Record. This takes the user to a web form where they can enter individual rows in the data set manually. You can also sort of get the nice preview of what the data you've already uploaded is, including on the far right, there's some audit history on which rows were added by what user, when was that row last updated, etc. So apologize, this is even really smaller. But just quickly looking at what the Excel template looks like from one of those. So controlled values that you defined in your definition file become drop downs in Microsoft Excel. You'll notice there's like some fields that are highlighted in dark blue. Those are the mandatory fields. So once you start typing in a line, it's giving a data publisher the cue saying, hey, these highlighted blue cells are things that you must complete in order for that record to be valid. If there's any rows that violate the sort of business logic, they'll be highlighted in red. So even giving a stronger indication to a data publisher that, hey, there's something wrong with this row. It's not going to pass. So this is, a pretty usable way to collect high quality data and ensure that users aren't able to put bad data into the system. Just showing here as well. Here's an example of what that web form interface looks like. So we use this in about 20 different instances on the Open Government portal for things like our proactive disclosures, as well as a few other reporting types of things. But with this, there's also a few limitations. One of the main ones is you need to be super familiar with CCAN in order to write that definition file for recombinant. So for the example that we were looking at on screen, the definition, the YAML file that you need to write for that is 1,300 lines of YAML. So this isn't really approachable for the average data publisher in a department. In order to configure a table that they might just update a few times. The juice really isn't worth the squeeze on that. And in order to deploy one of these new recombinant based data sets, you need to be logged into the server backend and run some commands on the server. So for that reason, it's not really usable by the larger open data publishing community. It's really just used by our core team at Treasury Board Secretariat. So, obviously there's a solution to that limitation, which we're under active development on right now. So we're going to call this new extension that we're working on Table Designer. And for this, what we wanted was the ease of publication of the core CCAN data store, along with the feature-rich functionality of CCAN recombinant, but without having to write, 1,300 line YAML files to define it. So in this new extension, we're going to be allowing users to use the CCAN data store as the main home for that data. Typically, when you're publishing open data, you're doing an extract from a system of record and then just publishing to the portal. But in this case, you're able to create CCAN data store native data sets that have that feature-rich functionality with the templates, the forms, etc. Um, um, Along with like really good API documentation on how to manage that data at the row level as well. And yeah, we're hopeful that this should sort of help to level the playing field between teams that have a full built-out modern data stack and those without it. This will allow teams that don't really have a good spot to store some of their open data to use the CKN data store kind of as like the data warehouse for some of their tables. Yeah, so with that, I mean, that's sort of like the big thing that I wanted to talk to was that new table designer feature that we have coming up. And that's really what I had to say. Thanks so much. And obviously, any questions?
That's fine. Is the idea of table designer to sort of delegate data design to the actual publishers and various ministries and so forth?
Yeah, so in terms of actually designing the data set themselves, we want that to be able to be done by departments. Now, if it's the actual individual data publisher that's designing it, or if there's, maybe someone else, such as like the domain expert of that data that's going to be getting released, that's kind of up to departments on how they want to use that feature. But really, it is to enable folks to have that feature-rich functionality of recombinant without having to write those big definition files. Yeah.
Okay, good.
All right. Thank you. Yeah.